Hey guys, Corrosive here with Signals Everywhere, and if you're looking to learn more about software-defined radio, make sure to smash that subscribe button and hit the notification icon because each and every week I'll be bringing you a new video to help you step up your SDR game. Today I'll be teaching you how to take your new KerberosSDR from the RTL SDR.com blog and set it up for radio direction finding. Don't go anywhere. You're watching Signals Everywhere. So before we can get started, we're going to take a look here. We have our KerberosSDR, a Raspberry Pi 3, new in the box, even though it came crushed from Amazon. It is in working shape. And here we have the case we'll be putting the Raspberry Pi in. It comes with a couple of heat sinks, a cooling fan, and a few other items such as a power supply, so that way we can keep the Raspberry Pi protected as well as extra cool while running our KerberosSDR software image. From here we can begin assembling our Raspberry Pi 3 case in preparation for the KerberosSDR software to be loaded onto the SD card. Now that the heat sinks have been prepped, we can go ahead assembling the case as well as installing the fan that goes on the top. This is going to help keep our CPU itself nice and cool while it's running some of the more intensive software activities that we'll need it to do for the KerberosSDR. So I made it a point to make sure that I purchased a case that included a fan. And of course, links to everything you see here will be included in the description below, so you can pick these up yourself for your own build. And as we put in the final screws here, we can go ahead and begin the next step of actually loading our KerberosSDR software onto our SD card image. From here, head over to the RTL SDR website and grab your KerberosSDR image. You can see I've already unzipped that here and selected the image file. Now we can select our SD card that will be loading onto the KerberosSDR, ensuring there's enough space on it, and hitting the flash button. We now wait for a little bit here and let Etcher do its job. Links to the software will be found in the description below, and I'll see you once Etcher completes its writing process to go ahead and set up a little radio direction finding fun back over on the KerberosSDR hardware itself. Before we begin using the KerberosSDR, we need to go ahead and power it up with our USB-C cable, ensuring that you're able to pull enough current to keep it up and running properly. We'll also need to take a micro USB cable from our Kerberos and plug that into our Raspberry Pi 3, ensuring that the Kerberos has a few minutes to boot before actually booting the Raspberry Pi itself. Once that is ready to go, we'll go ahead and connect power to the Raspberry Pi 3, and from here we can begin setting up the software configuration for some radio direction finding. With everything up and running, head back over to your PC or mobile device. We need to look for an access point called Kerberos Pi, and we're going to go ahead and connect to that. Once connected, go up to the URL bar. We're going to type in 192.168.4.1:8080/init to bring up our user interface. From here, we're going to go ahead and set our target frequency. In this case, it's going to be 446 is where I'll be direction finding. We also need to set our sample rate to a somewhat small value so it encompasses as close to we can just the signal we want. And then I'm going to set the gain levels for each SDR to match each other. And then we're going to save those to the Kerberos. From here, we're also going to enable the DC compensation to get rid of our DC spike, as well as set the filter, which is going to be about 30 kilohertz because we're looking to hunt down a 25 kilohertz signal. And then we're also going to put in a 100 fur size, which is a recommended default. We're going to update those values, leaving the decimation alone in this case. From here, we're going to start processing as well as start the spectrum display so I can show you a little idea of what the spectrum looks like from each of the 4 coherent SDRs within your KerberosSDR. We then need to go ahead and stop that spectral display before we can set our sync settings. In order to get our 4 coherent SDRs to sync together, we need to enable the noise source as well as the spectrum display. We'll go ahead and hit update here. And what we'll get is a display of where our signals appear in contrast to each other. And you can see by looking at the 3 distinct humps here that none of the SDRs are actually in sync with each other. So in order to do this, we're going to go ahead and press sample sync. And we'll wait a moment here. We should begin to see that all 3 of those merge into a single waveform, and that's how you know that your software-defined radios are in sync. Keeping in mind, we'll have to come back and do this anytime we change our target frequency or our gain. Now, once this is set up here, we're also going to go ahead and calibrate the IQ here. And I generally give this just a moment or two to do so before then going back and disabling both the noise source and the spectrum display. If you don't do this before you go to your direction finding, you're going to run into some problems. Now, before we can set up the antennas for direction finding, we need to change our 446 frequency into the wavelength in meters. We're then going to copy that, and I'm heading over to Google here. We're going to take that wavelength in meters, and we're going to multiply that by our spacing factor. In this case, we're going to use a spacing factor of 0.3, and this will give us our answer in meters of how we should space the antennas apart from each other. We're going to go ahead and convert that to centimeters, or if you prefer, convert it to inches. And we can see here in this case, we need to be 20 centimeters apart in our antenna spacing for this particular type of array setup. Now, there are two ways that you can set up your radio direction finding array. We can do the linear array, or we can do a circular array. Now, I'm going to show you how both of these are set up, but keeping in mind that that spacing factor, in this case 0.3, is something that you'll need to make note of before you make your mathematical calculations. So let's go ahead and take that 0.3 at 446 megahertz and set up a linear array first. So here you can see that I'm trying to hobble myself on top of the car, and we're using a simple measurement here to go ahead and space out our antennas equally in this linear array using just a basic tape measure here. So before we can enable direction finding on our KerberosSDR, we need to make our antenna connections, making note that in this view, number 1 antenna is all the way to the left, where number 4 antenna is to the right. So you can see I'm flipping my Kerberos over here, and we're making note of the numbers on the dip switches. These are intended to turn your SDRs on and off individually, but it's a great way to remember which antenna port is number 1, 2, 3, and 4. Here you can see I'm taking off the terminations that you need to make sure are attached whenever you're doing your sync setup for your IQ calibration. Once you have those detached, you can go ahead and attach individually each one of your antennas, making sure that you have antennas 1, 2, 3, and 4 marked in some way, shape, or form, because if you mix up the antennas in your direction finding array, you're not going to get anywhere near a reliable result because your KerberosSDR isn't going to properly understand which direction your signal is coming from. So make sure you have those in the correct ports. Now that the linear array is attached, we need to make sure that we're set up for the ULA, which is a linear array, with our spacing factor, which we chose as 0.3. We're going to go ahead and use music as our algorithm and enable the DOA application itself, and then hit the Update DOA button. From here, I've switched over to my mobile device and selected compass from the top of the page here. And so what you're seeing here is the compass I've placed on the left side of the screen, and video from my phone is being placed on the right. Now, as soon as I kick on my transmitter here, you can see that I immediately get a 0-degree indication showing that there's a signal directly in front of me. And as I move around the vehicle, you can see that with some pretty fair accuracy, this is tracking the location of the transmitting source. Now, a linear array is something we generally start out with because of its ease of use. And now, with radio direction finding, there's a chance of multipath and, interfering signals or something bouncing off of something else that can cause some problems with your signal. But the linear array is much easier to set up than, say, a circular array. And what I want to show you here, when I spin around to the back of the vehicle, because this is a linear array, it unfortunately cannot tell you whether or not the signal is in front of you or behind you. So that is one drawback of the linear array. You'll see it kind of bounces around here as I go from the front to the back. And then once I'm at the back of the vehicle, you'll see that the arrow spins right back forward to the 0-degree bearing. So now that we've done this, we're going to move to a circular array and show you how that works. Now I'm going to go ahead and set up that circular array. In this case, I'm keeping the same spacing factor of 0.3. And we need to make sure our antennas are oriented correctly. So I'm first placing antenna 1 with antenna 3 across from that. Then I'm placing down antenna number 4 with antenna number 2 across from that. So we need to make sure that those are oriented properly when they are connected to the KerberosSDR, so that way it is bringing those signals in the correct order. Otherwise, your direction finding is going to be just completely off. Now that we're set up for a circular array, we need to let the software know that. We make this change and then go ahead and hit the Update button, and we'll move back over to the phone. So now we can see that I'm back over on my phone doing a quick spin around the vehicle here with my circular array. And the purpose here is to show you that we can now see a full 180-degree view. Unlike a linear array, this can tell us the difference whether or not a signal is behind our vehicle or in front of our vehicle. Now that being said, you do see that the needle jumps around a bit more than it did with a linear array, and that is mostly due to the fact that there is multipath interference. Our signals are bouncing off other objects, and it is somewhat skewing the results. However, there are pros and cons to using a circular array. If you're just getting started, I would highly recommend you start with a linear array for simplicity. So that's all I have for you guys today. I hope that was informative, and if you know anyone else interested in radio direction finding, please share this video with them so that they may learn from it as well. I also want to give a quick shout out to all my patron subscribers, for whom without this would not be possible. You guys support me each and every month, and I cannot tell you how much that means to me. So if you guys like my content, please consider being a patron of the channel. You're going to get early access to videos, some behind the scenes stuff, and you might even get something in the mail from me. So if you guys like the content, I'd love to see you around. Hit that subscribe button, hit like so I know you enjoyed the video, and I will see you all in the next one.